Okay, so on a warm up, area of trapezoid. How are we gonna find the area of this?
Area equals parentheses base 1 plus base 2 times height divided by 2.
Good. So B1 plus B2 in parentheses times the height, all divided by 2. So in this one, it's 1.5 plus 3.3 in parentheses, that has to be in parentheses, times the height of 2.9, all divided by 2. And what does that give you? Okay, number 2. A bunch of 2's here. So we're going to have 2 plus 0.6 times 2 divided by 2, which gives you 2.6. Then on number 3, how am I going to put those numbers into the area formula?
4 plus 4 times 3 divided by 2.
Okay, 4 plus 1.4 times 3 divided by 2.
It doesn't order which way you put the base in, like in order, right?
No, that doesn't. You could put 1.4 plus 4. It's the same thing. Yeah. Gives you what? Alrighty. Okay, so on these triangles, how do we find the area of a triangle? Base times height divided by 2. So 8 times 4.5 divided by 2. 18 square miles. And then on this one, 5 times 1.9 divided by 2. All right, let's flip over and look at this.
Wait,
Yep.
so is a diamond the same thing as a was, or are they two different things?
What you think of as a diamond, what you've been taught in the past as a rhombus. Yeah. Yep. Okay, so today we're going to talk about the area of kites and rhombi. They use the same formula, so that's the reason we're just doing them on the same day here. Okay, so area of a of a kite or rhombus. You got that in my mind. So it's diagonal 1 times diagonal 2 divided by 2.
No parentheses?
No, not needed here. I mean, you could put them. Generally never hurts to put parentheses, but when they're needed, they're needed. Okay, so diagonal 1 times diagonal 2 divided by 2. And kite and rhombus use the same formula here. All right, so let's measure and find the area of these. So the diagonal is talking about like from here to here. Okay, so how long is this diagonal?
6.6.
About 6.6. Okay, so that's diagonal 1. Now diagonal 2. It's going to be right here. Yeah, I think we'll go with 7.7. Okay, so all you do is you multiply those two diagonals and divide by 2. So 6.6 times 7.7 divided by 2. So right here, 25.41. Okay, 25.41 what? Good. We measured in centimeters, so obviously that's the unit.
Square.
Squared. Area. It's always squared. Okay. Now, a rhombus actually is a parallelogram. So we actually have another formula to find the area of this. How do we find the area of a parallelogram? Yeah, just base times height, okay? So we could do that. We could measure the base here and then measure the height, just multiply those to give us the area of this, okay? So that would work. But another way to do it is doing the diagonal 1 times diagonal 2 divided by 2. So let's go ahead and do it like that. So let's measure from... So how long is that diagonal?
4.5.
Right at 4.5.
He said, I already solved it. I didn't even know what I ain't even. I thought you
Okay. How long is this one?
10.9. Wait, what? 10.8.
About 10.8 or so. All right. So we're going to do 4.5 times 10.8 divided by 2. And there you go. Diagonal 1 times diagonal 2 divided by 2. And then again, on this, it doesn't matter what order you put these in. 10.8 times 4.5 divided by 2. I'm going to give you the exact same answer. Okay, so let's look over here. On this one right here, we're looking for the area of this kite. So, and they list it like this. It's the same thing. 1/2 times diagonal 1 times diagonal 2. That's the same thing as diagonal 1 times diagonal 2 divided by 2. I just prefer to do it the way that I showed you. So we're going to do 8 times 15 divided by 2. What's 8 times 15 divided by 2?
60.
Okay, so 60 square meters. All right, next one. Okay, so if you'll notice what they're doing here is they're saying that this piece, they're talking about this from here to here is congruent to this piece from here to here. So this 12 is just talking about from here to the midpoint, basically. So how far is it going to be from here to here? 12. So you're right, the whole thing is 24. And then how long is this whole diagonal going to be? 20. So we have 24 times 20 divided by 2. Yep, 240 square feet. Okay, next one. One diagonal of a rhombus is twice as long as the other, and they've already got that drawn for you right here. One diagonal is twice as long as the other if the area of it's 169. What are the lengths of the diagonals? Okay, so we know that diagonal 1 times diagonal 2 divided by 2 gives you the area of that rhombus. Okay, so diagonal 1 times diagonal 2 divided by 2 gives you the area. So diagonal 1 times diagonal 2 divided by 2 equals the area. And we're just working backwards here, or to solve for x. Okay, so what do you think we need to do first here? Okay, let's get rid of the 2 first. Multiply by 2 on both sides. Which actually, it's fine to do it that way. It really is more work to do it this way, but that'll work. Okay, so those are going to cancel. We're going to have 2x times x left here. What's 169 times 2?
338.
Okay, 338. Okay, so right here, what's 2x times x? It's 2x squared equals 338. What would I do next? Okay, I got to get rid of this 2 right here first. Divide by 2. That way these 2's cancel the 1. That just leaves x squared. What's 338 divided by 2? 169. Which, we could have done this in way fewer steps. But we're good. We're still getting the same answer. So how are we going to get rid of this squared? Square root both sides. And x equals 13. Then if x equals 13, how long is this diagonal? 26, and this one's 13. Okay, on this one, so 22 times x divided by 2 equals the area of 92. Diagonal 1 times diagonal 2 divided by 2 equals the area.
Okay, so times 2.
Okay, let's go ahead and just think about this. What happens to 22 divided by 2? You can do it like this. 11, so let's just do it like that. That gives us 11x equals 92. Divide by 11. And what is 92 divided by 11?
8.36.
Okay, this last one. What's the area of this kite? Okay, so we're going to have some Pythagorean theorem going on this one. All right, this one right here is the 10. This one right here is the 6. And this one right here is the 17. Just so you'll know where those numbers go. Okay, so first of all, let's start off by finding this side right here. So this is a 90-degree angle right here. Let me put that in a different color. I'm looking for this side right here. So this side is 10. This side is 6. And I'm going to look for this side first. So how am I going to set that one up?
6 squared plus x squared equals 1 squared.
Yep. Because right now what I'm doing is I'm just looking at this triangle right here. Okay, the one I just shaded in. That's what I'm looking at for right now. Okay, so let's work this out. We have 36 plus x squared equals 100. Subtract 36. X squared equals 64. Take square root both sides. X equals 8. So this one right here is 8, which means from here to here is 8. So that whole diagonal right there is 16. Okay? We'll get to that in just a second. Now, I know from here to here is 6, but I do not know how far it is from here to here. So that's my next thing. So now what I'm going to do is I'm going to just think about this triangle right here. Okay, how long is this side? 8. We just found that, right? I just got that one's 8. I know that this side's 17, and now I'm looking for this side. So how am I going to set that one up in the Pythagorean theorem?
X squared plus 8 squared equals 17 squared.
Good. So we have x squared plus 64 equals 289. Subtract 64. X squared equals 225. Good. Take the square root of 225, and x equals 15. So I'll just erase all that for that now. Okay. So we know that this whole thing we said was 8 and 8 is 16. And we said this is 6, and we just found that this is 15. So how long is this whole diagonal right here? It's 21. That's 6 plus 15 gives us the total of 21. So this diagonal is 16 inches long. This diagonal is 21 inches long. So we're going to do 16 times 21 divided by 2. And so the area is 168 square inches. Okay, real quick on your assignment, just to go ahead and eliminate the confusion here real quick. So look at your assignment number 7. So on this one, you can see how it's got the congruent marks and it's x. So it's talking about x just from here to here, and so there's another x from here to here. So that whole diagonal is going to be x plus x, which is 2x. Okay? On number 8, it's pointing to that. Let's just say that the whole thing is x. So you're not adding it. It's just 1x for that whole diagonal. And then on number 9, it's obvious what it means, that just the whole diagonal is x there also. So just to help you out here, on number 8, you're going to do x times 20 divided by 2 equals 340. And then you'll solve for x. And while we're at, let me go ahead and do number 7. So number 7, you would have that whole diagonal is 2x. So on this one, 2x times 16.4 divided by 2 equals 104. And you'll solve for that. Okay, then one more thing on the very back. Number 20 and 21, the last two problems, are duplicates of number 8 and 9, so just skip number 20 and 21.